Hello, welcome sa ating next tutorial. So, design of two-story reinforced concrete residential structure using STAAD Pro and STAAD Advanced Concrete Designer RCDC. So, during the course ng tutorial natin, so probably meron tayong five main objectives. Yung number one is calculate wind pressure for components and cladding per NSCP 2015 and ASC 710. So, i-design number 2 is i-design natin yung roof truss and purlins per NSCP by LRFD method. Then, yung number 3, i-derive natin yung mga dead load and live load values per NSCP, which is yun yung gagamitin nating loading values doon sa ating STAAD model. And yung number 4, di-discuss natin yung seismic parameters input sa STAAD per NSCP 2015 UBC 97. And lastly, yun, along modeling yung STAAD model natin, i-analyze natin yon, then i-design natin yung concrete elements, uh, yung concrete frame elements sa STAAD Advanced Concrete Designer RCDC. So, yun yung beams, slabs, columns, and footings. So, ito yung project natin. Okay. So, typical 2 by 2 bay frame. So, 4 meters, 4 meters dito, then 5 meters, 5 meters doon. Then, may naka-overhang lang siya doon. May balcony doon, cantilever, which is around 2 meter with the curved beams. Then, yung truss natin is 2 meter height. Then, may overhang siya na 0.8. So, kung 4 meters to plus 0.8, so total 4.8 meters. Then, yung purlins spacing natin, 0.8 meters okay, on centers. And yung truss spacing natin is 2.5. So, yung mga trusses, yung purlins natin yan, dito mas madali kasi i-discuss dito. Okay, so minodel ko siya sa Pro Structures, Bentley Pro Structures. Hindi to kasama sa tutorial, no? So, minodel ko lang para mas madali kong may discuss yung project natin. So, parang ganito yung framing, yung structural framing ng project natin. No? So, ito yung truss, 2 meter height, then 4 meters plus 0.8, so 4.8. So, yung angle ng truss natin, bali, so 2 divide 4.8, then i-inverse natin tangent, so around 22.62 degree. So, yun. Yung yung roof slope natin is 22.62 degree. Then, yung roof mean height natin para sa wind load calculation is 7 meters. So, 3 meters, 3 meters. And yung kalahati ng 2, 7. So, but hindi ko in-include yung 1.8 kasi nakabound yun sa soil. So, yung roof mean height calculation is galing lang dito. Okay? Sa level na to after 1.8. Okay? Yun lang yung mga tatamaan ng wind. Okay, so ito yung project natin. So story levels, putting to ground floor 1.8 meters, ground floor to second floor 3 meters, then second floor to roof beam, so 3 meters, then roof beam to apex, so 2 meters, so total 9.8. Ngayon, structure category natin, okay, from NSCP tables, okay, standard occupancy structure, so all structure housing occupancies or having functions not listed in category 1, 2, 3, and 5. Okay, so itong 1 and 2 essential. 1 is essential facilities, 2 is hazardous facilities, and 3 is special occupancy structure. So for offices and residential, so okay na itong occupancy, occupancy category 4. So, project location in Malolo City, Bulacan, seismic source type A. So, yung project is 40 kilometer okay, from the known seismic source. Okay, so sukatin nyo lang, no? I-plot nyo yung project location nyo, then sukatin nyo from the fault, then makukuha nyo na yung distance. So, since 40 kilometer yon, so hindi siya within 15 kilometer. So, ang mga magiging values natin dyan is 1.0 lang. So, pagdating natin sa seismic, ma-discuss natin ito mabuti. Okay. Then, so, yung wind speed natin, so sa Bulacan is around 250 kph. Ayun. And baka malito kayo dito, no? I-check nyo yung nasa ilalim. Category 3, 4, 5. Okay? May tatlong wind maps kasi doon sa NSCP. Okay? May iba-ibang wind velocity values yon. So, ito 1, 2, and 3. Okay? So, category 3, 4, 5. So, mas less yung wind velocity dyan, which is ito yung ginamit natin. So, 250 kph. Then, and ito yung para sa category 2, ito yung para sa category 1. Okay, loadings. Ito yung loadings natin. Okay, so hindi mo natin i-discuss yung concrete frame, no? Kasi ang i-design natin ngayon is yung purlins tsaka yung truss. Okay? So, ito yung mga loadings natin. Okay, so mamaya i-discuss natin to pag nag-loading na tayo sa truss. So, wind parameters natin, velocity of wind is 250 kph, importance factor is 1.0, then exposure B, typical residential structure in urban area. Okay, so para dun sa unang objective natin, calculate wind pressure for components and cladding per NSCP 2015. So, ang gagamitin natin dyan, meron kasing dalawang procedure or tatlong procedure ng calculation ng wind sa NSCP. Merong analytical procedure, merong simplified, meron pa yung wind tunnel. So, since simple lang yung structure natin, simplified method lang yung gagamitin natin. Okay? So, paano siya ma-qualify as simplified? Kailangan daw yung building natin is yung height is less than 18 meters. Yung building height natin is 7 meters lang. So, qualify yung building natin. And kung imagine mo yung 18 meter, it's around 6-story building. 2-story building lang yung i-design natin. So, ayan, sa simplified procedure tayo. Okay. Ito yung formula para sa pag-calculate ng PNET. Okay? PNET, lambda, KZT, PNET 9. Okay? Actually, typo error siguro to. Dapat ito PNET 9. 30 is 30 feet siguro. No? PNET 9 is 9 meters. Okay, anyway. Ayun, PNET 9 yan. So, lambda is adjustment factor for building height. Okay? Nasa figure daw na to, which is, ito na yun. Okay? So, exposure B tayo. Then, yung roof mean height natin is 7. So, consider ko 7.5. So, 1.0 lang yung lambda factor natin. Then, yung KZT naman, merong rigorous calculation yan just to simplify the calculation. So, i-assume ko na lang yan na 1.0. Then, yung PNET 9, it's not PNET 30. Madali lang yan. Okay? Madali lang i-calculate yan. Using tables lang yan. Okay? So, dito, ito yung tables na yun. Yan. Okay? So, para sa components and cladding. Okay, take note, no? So, take note, kailangan yung kukunin nating forces is para sa components and cladding, hindi sa main wind force system. So, ayun, ito yung definition sa ASCE 710. So, CNC, which is components and cladding, elements of the building envelope that do not qualify as part of the main wind force resisting system. Main wind force resisting system is an assemblage of structural elements assigned to provide support and stability to the overall structure, generally receive wind loading from more than one surface. So, merong magandang komentaryo si ASC is 710 dyan. Okay? So, yun. Cladding receives wind loads directly. Component receives wind loads directly or from cladding and transfer to the load to the main wind force resisting system. Examples of components include fasteners, purlins, which is yung didesign natin, purlins, gears, studs, roof decking, and roof trusses, which is yung i-design natin. So, kaya ang dapat natin na gamitin na forces na wind pressure doon sa purlins and roof trusses is galing sa components. And